Welcome to this explainer. Pull up a chair and get comfortable. Today we're doing a relaxed but honestly pretty deep dive into a fundamental computing concept that trips up, well, absolutely everyone. We're talking day one beginners all the way to seasoned veterans who've been coding for decades. We're going to look at a hidden pipeline that processes literally every single piece of data you interact with. And we're going to figure out why we almost always blame the wrong part of that pipeline when things inevitably go sideways.
Right, so you know the feeling. It's late, you're tired, and you send some data to a system, maybe an API or a command line. But instead of just working, it spits back this massive, terrifying red wall of text screaming invalid syntax or a malformed input. Your immediate reaction? Probably the exact same as every developer on Earth. You let out a heavy sigh, throw your hands up, and go, "Come on, my data's perfect. This parser is completely broken." But I want to pose a question to you today to challenge that automatic assumption. Is your parser actually broken, or did the system just hand your perfectly good data to the completely wrong department?
I'd love for you to keep this quote in the back of your mind as we walk through this. Understanding this separates someone who uses tools from someone who understands how tools work. This isn't just, random technical trivia to memorize. It's a total mindset shift. Once you really grasp the fundamental difference between how data is routed and how it's parsed, it's going to completely reframe how you approach software errors from here on out. You'll stop blindly guessing, and you'll actually start investigating like a seasoned engineer.
All right, here is our roadmap for today. 1. The broken parser myth. 2. Anatomy of input processing. 3. Real-world routing errors. 4. The mental model analogies. 5. Common causes of failure. And 6. Practical debugging strategies.
Section 1. The broken parser myth. Why we blame the wrong culprit.
Moving right into Section 2, Anatomy of Input Processing, the journey of raw data.
So, why do we always blame the wrong guy? Well, when an error happens, the parser is the component that actually throws that loud, highly visible error message. We see it complaining, so naturally we blame it. But the core insight here is that in almost every case, the parser is perfectly fine. It's doing exactly what it was programmed to do. To understand how that happens, we've got to trace the literal journey of a piece of raw data from the moment it enters a system to the moment it crashes it. Every system that handles input follows a general three-step pipeline. Step 1 is the input. This could be a text string, a network packet, an HTTP request, a voice recording, you name it. But here's the secret you have to internalize. Input is just raw, meaningless data. A stream of bytes. It looks like absolute gibberish and has zero inherent meaning until a downstream system acts on it. Steps 2 and 3 are where the magic and the tragic mistakes actually happen.
Step 2 is the router. Think of it as the dispatcher. It's a decision-making layer that answers just one single question. Given this input, which parser should I hand this off to? It's kind of like a frantic mailroom worker. This worker does not read your letters, they don't understand your content, they just make split-second decisions based entirely on shallow, surface-level signals. They're literally just glancing at the zip code on the outside of the envelope. In the computing world, that zip code is a file extension, a port number, or maybe an HTTP content type header. The router sorts the mail without ever once opening the envelopes to see what's inside.
Then we hit step 3, the parser. This is the interpreter. It takes that correctly routed envelope, opens it up, and actually tries to extract meaning from the contents using deep grammar rules, rigorous schema checks, and semantic analysis. It does the heavy lifting of true understanding. But, and this is a massive but, it can only do its job successfully if the mailroom worker handed it the right materials. If a parser designed to read plain text is suddenly handed a complex, compressed video file, it panics. And when a parser panics, it isn't quiet about it. It throws a massive stack trace, halts the system, and screams in red text on your monitor.
Let's look at Section 3, Real-World Routing Errors, when good inputs go to wrong places.
To show you how universal this is, and to prove this isn't just some niche web dev issue, let's look at file extensions on Windows. Imagine you have a perfectly valid JSON text file, carefully formatted and totally bug-free. But you're in a rush, and you accidentally save it as data.exe. What happens when you double-click that file? The Windows router, which in this case is the shell, sees that .exe extension and dispatches it straight to the OS loader to execute it as a program. The loader attempts to parse your simple JSON text as compiled machine code. Naturally, it violently crashes, probably throwing up a scary memory access violation. But is the OS loader broken? Of course not. It's designed to parse executable formats. You just sent JSON to a machine code parser. That is a textbook classic routing error.
Here's a subtle one that catches us all out, especially those of us who basically live in the command line. Let's say you're deep in your terminal. Muscle memory takes over. You mean to use Git to look at a log graph, but your fingers automatically type docker log -graph. The Docker CLI parser instantly yells at you that -graph is an unknown invalid flag. The router here, your shell, correctly saw the word Docker and dispatched the entire command string over to Docker, but your human intent was Git. This is a human routing error happening right at the keyboard. The Docker parser isn't broken in the slightest. You just routed your command to the wrong tool entirely.
Compilers do this exact same thing. Say you write a beautiful, bug-free Python script using the standard Python def keyword. But maybe you were working on a different project earlier, and you accidentally saved this new file as main.rs, which is the extension for a Rust file. You go to compile it. The router sees that .rs extension and happily hands the file over to the Rust compiler. Now put yourself in the shoes of the Rust parser. It opens the file, expects to see the word fn to declare a function, but instead it sees def. It has literally no idea what def means, so it throws a massive syntax error. The Rust compiler is totally innocent here. The file extensions simply force the router to send Python code to a Rust parser.
Let's contrast those routing errors with an actual, genuine parsing error, just to be super thorough. Let's look at natural language processing. You're in your kitchen, and you tell your voice assistant, set a timer for banana minutes. The audio router hears the wake word and correctly sends the audio stream to the NLP parser. The routing here was absolutely perfect. These routers are incredibly sophisticated today. The parser successfully identifies your core intent. You want to set a timer. But when it applies its basic grammar logic and tries to parse the word banana as a duration of time, it completely fails. The request genuinely makes no sense to the grammar rules of time. That, my friends, is a true parsing error.
Section 4. The mental model analogies. Locking the concept into long-term memory.
Okay, let's just take a breather. Clear your technical mental palette, forget about JSON, compilers, and HTTP headers for a minute. Let's go out to dinner.
Imagine an incredibly busy, noisy international restaurant on a Friday night. A customer walks in the front door speaking French. That's a raw input. The host standing at the front podium is the router. Their job is quick and stressful. They hear French and they immediately seat the customer in a section with a French-speaking waiter. The waiter is the parser. They take the order, understand all the nuances of it, and process it with the kitchen. Now, what does a routing error look like in this scenario? The overwhelmed host mistakenly seats the French-speaking customer in a section of a Japanese-speaking waiter. The waiter walks up, hears the French, doesn't understand a single syllable, and the entire ordering process fails on the spot. But the Japanese waiter isn't broken. They are a fantastic waiter. They're just the wrong parser for that specific input. Now, what if the host gets it right, seats them with the French waiter? But the customer asks for a flying coffee. The waiter understands the French words perfectly, but the request itself is completely invalid. Boom, that is your parsing error.
When we look at this separation of concerns side by side on this cheat sheet, a really clear pattern emerges. The router's scope is incredibly broad. Its knowledge of the data is extremely shallow. It acts super fast, and crucially, its failures are almost always silent. It just quietly sends data to the wrong place and dusts off its hands. The parser's scope is narrow and highly specialized. Its knowledge is deep, it's a bit slower to analyze, and its failures are loud. Really linger on that difference between the silent routing failure and the loud parsing failure. Understanding that dichotomy is the absolute key to mastering system debugging.
Section 5. Common causes of failure. Why routing goes wrong. We know what a routing error is now, but what actually causes these silent failures out in the wild? Well, it usually comes down to a few very common culprits. First, misconfigured defaults. If an operating system defaults to opening every unknown file type in Notepad, it's going to route poorly, and you're going to see a lot of garbled text. Second, proxies and middleware. Think about a load balancer sitting in front of your servers. If it accidentally strips away your content type header in transit to save bandwidth, the router at the destination has absolutely no zip code to read. It has to guess, and it might guess wrong. Then, of course, there's good old human error. We type the wrong extension or point our code to the wrong API endpoint. Sometimes the input is just ambiguous by nature, like a file with no extension at all. And finally, version mismatches, where a version 1 client tries to talk to a version 2 router, but the routing signals have completely changed between versions. Remember, the router can only work with the metadata it's given.
Section 6. Practical Debugging Strategies. Transforming guesswork into systematic investigation.
So how do we actually fix this? How do we take everything we've learned and transform our frantic late-night guesswork into a calm, systematic investigation? Here is your actionable checklist for the next time you hit a wall. Whenever you hit a stubborn syntax error, follow these steps like a seasoned pro. First, trace the input pipeline. Map out exactly how the data travels from your keyboard to the final server. Second,
And this is arguably the most important. Isolate the parser. Extract the raw input exactly as it was sent and test it in a standalone validator online. If your JSON validates perfectly in a standalone tool, the parser is completely innocent. You need to look upstream. Third, check your routing signals. Are the headers, the extensions, and the ports actually what you think they are? Finally, force a manual route. Rename the file extension yourself or manually change the HTTP header using a tool like Postman to see if a different parser handles it successfully.
I want you to keep these diagnostic questions in your back pocket for your next debugging session. Ask yourself, what did the system think it was receiving based on the routing signals? What raw bytes did it actually receive? Does the data validate completely on its own? And what happens if I force a new route? This simple framework stops you from blindly rewriting code that isn't actually broken.
If there's one massive paradigm shift to take away from this entire explainer today, it's this. When a system crashes, halts, and yells at you about syntax, take a slow breath. Remember that the parser is usually innocent. The router is often the real culprit, quietly hiding in plain sight, having silently handed off a job to the completely wrong worker. I'll leave you with this final thought. The next time you encounter a stubborn error message, before you start rewriting your data, before you start pulling your hair out or blaming the compiler, will you stop and ask yourself, did the right parser even get called? That single, simple question will save you hours of frustration and completely elevate your engineering mindset. Thanks for hanging out with me to figure this out. Take care and happy debugging.